Hi, I'm Pete Warden, and this is the screencast for TensorFlow for Poets. I'm going to be walking you through exactly how to download and run TensorFlow on your Mac laptop in order to create your own image classifier. And this is an accompaniment to the blog post that you'll see me referring to. I just wanted to have a screencast to make it absolutely clear what I'm doing in case there's any confusion. And I will dive in with Docker. So as I mentioned in the article, Docker is a way of easily running Linux on your Mac laptop, and it's free. You can download it, and I'm going to show you how to download it now. As I mentioned in the article, it's actually likely to change the exact steps, but you can always go to this page at docker.com to see how to actually install the process. But I'm just going to show you how it is at the start of March 2016 on my Mac laptop. So I'm going to go to docs.docker.com/Mac, and that's the getting started page, and you can read through and then you go to the first step, and the first step is actually downloading the Docker toolbox. And I already know that I'm on a recent enough version, so I'm going to skip checking that and then just go to the Docker toolbox link. And you can see there's a couple of buttons here, one for Windows, one for Mac. I'm on a Mac, so I'm going to click on the download there. It's about 170 megabytes, so it takes just under a minute on my machine. And once this is downloaded, I'll actually run the installer. You can see you get a preview of what we're going to see in the installer. You basically just click through all of the standard options, so I'm just going to go through and just choose all of the defaults. So you see it's appeared in my downloads folder. I'm going to click on it to start the installation. I'm going to click continue, click continue, click continue. Use the default installation location, so I'll just click install. I'll enter my password for this machine so that it's actually got permission to install. Now it's finished, and I'm actually going to click on the Docker Quick Start terminal to open up the terminal, and you'll see I mentioned that in this step here. So in the installer, just click on that Docker Quick Start. It opens up a new terminal window, and it goes through a bunch of setup scripts to get Docker ready. And that will again take maybe a minute or so. And while it's doing that, I'm just going to click continue and close the installer. And don't worry if this step takes a while. It's busy doing stuff in the background. And there you see the ASCII out of the whale, and it looks like it's actually installed correctly. So, as per the blog post, you see that in step 1 of the instructions, once you've installed, it asks you to try running the hello world, docker run hello world command at the prompt that you see over here. So I'm going to actually copy that from the blog post using Command C and then do Command V to paste it into the terminal there. And see, it's downloading a small image, and then once it's done, you'll see that it's output hello from Docker and a message showing that your installation appears to be working correctly. And this is what we would hope to see. This is what all that the Hello World virtual machine actually does. You can see that kind of shows up here. And so the good news is we've got Docker installing and running, and that means we can actually download the image for TensorFlow. And when I say image, this is effectively a saved file with a Linux setup that already has TensorFlow pre-installed. So we're going to use this Docker command here that's in the blog post to download and run that pre-installed TensorFlow Linux virtual machine. And this is going to take a little while because there's maybe, I'm estimating maybe around a gigabyte's worth of data to download. So we'll just wait while the downloading takes place. So the download is completed, and we're actually now inside a Linux virtual machine, and it already has the TensorFlow source code downloaded and all of the dependencies and things set up. So if we go to the blog post and we type the command ls/TensorFlow, which will list the contents of the /TensorFlow directory inside the Linux machine, we'll see the root of the source code for TensorFlow, which is what we're going to need to build the example that we're going to run. So now one thing that is a bit complex is that Docker is designed for a lot of web applications and making running web applications that want to run on Linux very easy to run on OS X. It's a common use case, and they don't really care that much about CPU performance. They're not generally doing a lot of heavy computation, but we're going to be doing a lot of number crunching, so we actually have to do some special tweaks to make sure that the Linux virtual machine that's running actually gets access to all of your laptop's resources, or the process of doing the training, creating the image classifier would take a very long time. So we're going to start by opening up the VirtualBox application, which Docker has installed, and we're going to change some settings there to make sure that the virtual machine is able to run as fast as possible. So to find the VirtualBox application, what I like to do is actually use the Spotlight search and just type in VirtualBox and then hit return. So I'm going to cancel on that. I just happen to have an old version running, You probably won't have all of these. These are just old virtual machines that I've used with VirtualBox before, but you should have one that's called default, which is the one that's being used by Docker, and it should show that it's actually running. Now, in order to make any changes, we actually have to close that machine and choose right-click on default and choose Close ACPI Shutdown, and I'm going to choose Continue there, and if we go back to our terminal, you'll see that we've been kicked out of the Linux machine because it's been shut down by VirtualBox. Now it's in powered off state, and we can choose Settings, and we go to the System tab, and you can see that at default it's only got 2 gigs of memory, and in this machine we actually have 16 gigabytes of memory. So we want to make sure that it's actually got a good amount of memory to work with so it can run as fast as possible. So I'm going to drag that up somewhere, it doesn't have to be exact, but somewhere around 12,000 megabytes or 12 gigabytes. And then also for the processor, I know in this laptop and probably in a lot of modern laptops we have more than one CPU, so I'm going to use the green line as a guide to drag that up to 4 CPUs, which is going to help us a lot. Then I'm going to click OK. It's going to save the settings. I'm going to right click and choose Start Headless Start, and that will start the virtual machine. Then we're going to go back to the post to find what we need to run next. It's going to be this docker run command, and assuming if we go back here we see that it's actually running now, so we can go back to our terminal prompt and paste in the docker run command. Like, it may not have quite started up far enough yet, so there we go. I actually ran that first copy of the command too early. The Linux virtual machine hadn't fully booted yet, but if you see the cannot connect to Docker daemon, just wait a few seconds like I did and then just try it again. And you should now have a much faster virtual machine than you had before. So what we need now is to grab some images to classify, and I'm going to actually do some of these commands to download the images we need from the OS X command line. So to get to that, you'll see in the Linux one you see root at on the left hand side before the prompt, and that shows that you're in a Linux virtual machine. If you type exit to exit out of that, you'll find yourself in something that looks more like Peter's MacBook Pro, probably with your own machine name there instead. And that shows you're in the Mac terminal. And we want to run the following commands in the Mac terminal, and what they're doing is they're creating a new folder in your home directory, and they're pulling down the set of flower photos that I actually have set up as an example to help with this tutorial. So I just command copied those commands, and I'm just going to paste them into the OS X terminal here. And you can see that it's downloading all of the files again. It's around 220 megabytes, so it shouldn't take too long. And I'll just hit return at the end, and that should open up a Finder window that actually shows the folders full of images that have been downloaded, and you can see the Daisy folder, unsurprisingly, has a series of all sorts of different Daisy photos that are Creative Commons images taken by people, and you can check out the license here if you're going to be copying this around, just so that you make sure you give attribution. And you can see Dandelion is similar. It has lots of different photos of dandelions, same for tulips. And the key thing here is that if you want to create your own classifier, you just create your own folder structure like this, where you put in, you create folders for each category that you care about, and then you put in photos of those objects inside each folder. And there's more details on the main tutorial on the TensorFlow site about how to do this, but ideally, if you can get at least a few hundred photos of the objects you're recognizing, then you should be able to run that with your own objects that you care about instead of flowers. But to get started, this is just an example set of flowers that I'm going to show you how you can build a classifier with. So going back to the blog post, we now need to run the docker command, and this time we're doing something a little bit different in that we're running it with a shared folder option, the -v option, which tells Docker to actually map a folder, the folder that we created, the TF files folder we created above, that's on our Mac file system, to the /TF files folder inside the Linux system that we're going to start up. And that allows us to share the flower photos and other files like the output classifier that we create between OS X and the Linux machine. And so when the Linux machine is powered down, you can still access the output, and if you have your own images, you can just organize them on the Mac side and then just point the Docker virtual machine at those, as long as you put them in the TF files folder in your home directory. So anyway, we've just copied this command line. I'm going to go back to the terminal and just paste that in. And then I'm going to hit return. And you'll see, because it says root at the start, we're actually in the Linux machine again. And if I look in the TF files flower photos folder from the Linux machine using the ls command, you'll see that there's actually a whole bunch of folders, as you would expect, showing all of the different flower types. So one thing that's a bit unfortunate is that we need to actually update the code. The code that we're going to be using for this example was not in the 0.71 release. It just came in a little bit later, so it's not included by default in the Docker virtual machine that we're using. But the good news is we can actually update the code to the latest version by making a few changes. So one of the things we need to do is just give Docker some identification. It doesn't have to be anything useful because we're not going to be checking any code in. So this is just to prevent Git from raising some errors about identification. So we're going to copy the git config commands, paste them in, just to set up Git with some default information. Then we're going to go to the TensorFlow folder. We're going to do a git command to grab the latest source code. You see it's working hard, and for mysterious Git reasons, it wants you to actually make an update here. So I'm just going to enter :quit on the keyboard and press return because this doesn't matter, and it's gone ahead and actually updated the code. Now, just to make sure we're all on exactly the same page, I'm actually going to roll the code back to a version that's after the 0.7 release, 0.71 release, but actually has the example code in it, just to make sure everyone's on exactly the same version of the code. And you just need to copy and paste the git checkout and then the long string of letters and numbers from the post, and that actually sets the version to an exact version that we know works. So after all that, we should now be ready to actually build the code. And again, we just make sure that we're in the TensorFlow folder, which you should already be, but we'll just change the directory there. And then we're going to run this Bazel command. Bazel is the build system that Google has open sourced that we use for TensorFlow. And we're going to use a couple of options. We're going to do -c opt to optimize, and we're going to do -c opt equals -m avx, which tells the build system that it's safe to use the avx processor extensions, which help speed things up a lot when we're actually doing the training. And all modern laptops should have that, so we should be safe to use that option. So I'm just going to hit return here, and then this building process will take 5 to 10 minutes, possibly, depending on the speed of your machine, and you'll see lots of warnings. They're expected. Don't worry, it's not something wrong on your machine. We're working to reduce them, but it should whir away and actually build the code that you need to build your own classifier. And now it's completed building, so we're going to run the retraining process using this command here from the blog post. And one thing to notice is we're actually setting a bunch of the options to use the shared TF files folder on the Mac, so that the outputs, especially the output graph and the output labels that are the model classifiers, actually get stored on the Mac, and we can reuse them between virtual machine runs so that they don't get deleted. And you can see we're also passing in the image directory here. So if you have your own images for future runs, you'll just replace the TF files for our photos argument here with your own top-level directory. So I'm going to copy this command and paste it in to the Linux virtual machine and hit return. And you'll see it will start by downloading the original model, which recognizes 1,000 different types of objects, but not the flowers that we actually care about. And what we're going to do is actually leave most of that model the same, but just retrain the top layer so it recognizes the flowers that we care about. And it's going to spend some time now, actually maybe 20 or 30 minutes, actually creating bottlenecks, which is the informal term that we use for running the network all the way up until the final layer, and then storing the results of everything up to the final layer, so that as we retrain a new final layer, we don't have to run the full network to get the results for a particular image just before the final layer. So this is an optimization to cache images that we're going to be looking at repeatedly during the training process. And if you want to know more about what's happening there, you can actually go to the tutorial, which is on the main TensorFlow website, and read all about bottlenecks and how they're stored and what they are useful for. And you will have plenty of time, because you'll be waiting 20 or 30 minutes for all of this bottleneck completion to finish. You can see it's up to 300 now. There's about 3,700 images in total for it to analyze, so you can see it will take quite a while. Now you can see it's actually on the training stage. It's created all the bottlenecks and is actually trying to retrain the top layer. And this will itself take a few more minutes. And if you're interested in more details about what's happening, again, you can go to the tutorial and look through the training explanation. And you'll see a step number here. It's going to run 4,000 of these steps. So you can see it's about a quarter of the way through so far. You can see training is finally finished, and the accuracy that it's reporting is 89.6%, and we can now try out the classifier that you've created. using a different TensorFlow program. So go back to the blog post. You can see we have an example of using the classifier here. And what this program is going to do is it's going to load the graph that you just created to recognize flowers, and we're going to pass in one of the image files just as a test. And you can put in whatever image file you want here. So if you have other daisy photos or other flower photos you want to test it with, you can just replace this part of the command line with a pointer to your own image. So I'm going to select all of this, then just copy it, and then paste it into the terminal here, and then hit return. And this is going to build the C++ label image example that will actually load the graph and run it against the image that you've supplied. And again, this is going to build it first, which will take a few minutes, but then once it's built, it should output information about the image and its best guess. And hopefully we'll see that it guesses correctly that it's a daisy, but we shall see. And there we go. We see it's guessed daisy as the top category with a score of 0.997. You can see all of the other scores are much, much lower for all of the other different flowers. So I've just built my own classifier for these flowers. Hopefully you've been able to follow along and build your own too. And if you go back to the blog post, you'll see some notes on next steps for things that you could actually do with this classifier. And thanks for joining me. I hope you managed to get on okay with this, and I look forward to seeing what you managed to build.